Hi everyone, my name is Mohammed Atoum. I'm from IBM and I'm so pleased to be here with you today, all the way from the United Kingdom, to talk about how you can maximize your app's connectivity with IBM MQ. Before we dive into the world of IBM MQ, I'm going to play you two familiar sounds that you probably have heard before. Two everyday scenarios that are more connected than you think. They both depend on a technology that is secretly powering our lives, IBM MQ. So buckle up as we explore this hidden engine that is driving our modern world, and it's secretly linking modern enterprises together and increasing their communication and driving it seamlessly. These impressive stats will give you an idea on how important and crucial IBM MQ to the world's top industries. Picture this: 90% of the top 100 global banks, 80% of the top 20 telecommunication companies, 73% of the top 100 Fortune companies, and 90% of the top 20 insurance firms. They all depend on IBM MQ on a daily basis. This technology is the backbone for the world's most prominent enterprises and organizations. It's like the hidden glue that is sticking all of these enterprises together and making them function seamlessly and reliably. So before we dive deeper into IBM MQ, let's take a step backward and understand really what enterprise messaging is. Has anyone heard of enterprise messaging before? Okay, so I'm showing you something new. So usually when we say messaging, most people think of SMS. They think of one of the most popular messaging apps, Messenger, WhatsApp, iMessaging. While those apps are great for keeping up with your friends and family, enterprise messaging is designed to handle the more crucial and high-stake communication needs for enterprises, and specifically large ones. So imagine a world where thousands of employees, systems, and applications, they all need to communicate together reliably and efficiently, and this is where enterprise messaging comes in. So you might not see it on your home screen, but enterprise messaging is behind the scenes doing all of the work needed to power the organizations that we rely on a daily basis. So in the concept of enterprise messaging, there are two things: message producers and message consumers. Message producers are applications that send a message to the messaging system. And message consumers are applications that receive that message from the messaging system. And the messaging system acts as a mediator that stores the messages and delivers it to where it's supposed to be in the most reliable and efficient way. So you might be wondering, what's the difference between enterprise messaging or REST? Have anyone heard of REST before? Yeah? So REST is the representational state transfer, which is a web-based architecture that uses HTTP as its communication protocol. And there are some similarities between enterprise messaging and REST, but technically, the way that they approach message delivery and communication is slightly different. So REST basically exposes its resources over HTTP, and you can request them through POST, GET, DELETE, and more. And it's used for web-based APIs that can be connected and used by applications, IoT devices, and mobile devices, and so on. On the other hand, enterprise messaging acts as this mediator that delivers the messages between applications in the most reliable way from where it goes to where it's supposed to be. So while REST can be used for asynchronous messaging or asynchronous communication, it is really not designed for that. It is designed for synchronous communication over HTTP. And while it is great for web-based APIs, it is really not ideal for asynchronous communication as enterprise messaging. The cool thing about IBM MQ is that your applications will need to communicate with each other, but they don't really need to be programmed in the same language. So you can have multiple applications in a certain language, and they will be communicating with a bunch of other applications written in a different language. Furthermore, your applications don't have to live on the same cloud or environment to communicate. So you can have multiple applications living in one environment, and they will be able to communicate with other applications in a whole different environment. And the more applications we have, the more we will see the value of IBM MQ. It acts as this universal translator that translates the communication between applications. And you can think of it as this global village, like this conference, for example. People coming from different backgrounds, different languages, we're all here to collaborate. That's exactly what IBM MQ does. So the number and the different types of digital components that makes up a typical enterprise has blown up in recent years. In early 2000s, it was typical for an organization to have most of its digital components, like its systems, applications, and services, hosted on its own data center, under their control. However, with hybrid multi-cloud adoption and digital economy, this has transformed. Companies now are embracing multi-cloud and the hybrid IT strategy. And in fact, Gartner predicts that by the end of 2023, over 75% of small, medium, and large enterprises will have embraced and adopted multi-cloud or hybrid IT strategy. And this can be used to provide many services. Infrastructure as a service, you just heard about it. Software as a service, take Salesforce as an example. And also, in addition to public cloud, companies would like to utilize cloud technologies for their own private cloud purposes. So for example, in their own data centers, to spin up additional computing resources or virtual servers to handle the consistent messaging needs and to respond to spikes whenever they need to, and to implement redundancy for high availability. The way that companies communicate with their clients and their customers have emerged over the years, and especially since the pandemic. Since the pandemic has forced most communications to be digital. Banks can no longer rely on their customers to walk into their branch to do their banking needs and activities. Actually, customers now are expecting banks to provide them with a solution in which they can do most, if not all, of their banking needs on their mobile devices. Retailers can no longer depend on customers walking into their branches and purchasing items. They have been disrupted by the fact that over a quarter of their sales are being made online. So companies that are not embracing this digital economy are being left behind, while those that are embracing it are having a competitive advantage in the market and are actually dominating it. So as I said, enterprise messaging connects all of these digital components and their data in the most highly available, scalable, and reliable way. And IBM MQ allows you to do just that and have all of these digital components connected in no time. So think of MQ really as the wiring in the building that's moving the current between the outputs and the inputs to generate electricity and to make sure it is there in the right place. However, you wouldn't buy a house without electricity. And so many companies, they will not be able to function without MQ. And we have seen the slide in the beginning with all of these large organizations and top enterprises that are relying on MQ on a daily basis. And we all know that electricity is hidden, and so is MQ. So really, MQ is the wiring between all of these digital components. And we've all experienced this situation where we had an electricity outage in our homes, and we saw how annoying it can be, and we felt the impact right away. We can't do the most mundane things. We can't prepare food. We can't see at night. We can't do like the simplest things. So the question is, what would be the impact if tomorrow MQ ceases to exist? So why do you need MQ? As we all know, message producers, and as I mentioned previously, they communicate with message consumers. And they send a message, and it goes from the producer to the consumer as easy as you can see here. However, what would happen if the message that goes from the message producer, while it's going to the consumer, there's a problem with the infrastructure or the servers? Or what if the consumer is not ready to take on that message at that time? Well, that's where the value of IBM MQ comes in. IBM MQ is IBM's leading enterprise messaging solution that is facilitating the enterprise's most critical communications. So it has this message queuing technology that is a safe place for messages. And it is a safe place because once a message producer sends a message, it gets stored in this queue, and MQ waits for everything to be up again before it delivers that message to the receiving application. So if the application is not ready, or the application is not online for any reason, there's a problem with the server or the infrastructure, it will wait and will hold that message in that queue until it is up again, making sure that no messages are duplicated or lost. And this is quite important with critical messages, especially with enterprises like banks, insurance companies, and so on. So this is what we call asynchronous communication or messaging. And the closest example I can give is we have phone calls and we have SMS. When you call someone and you want to deliver them some information or you want to talk about something, and they don't pick up the phone, and provided they don't have the mailing service, you won't be able to give them that piece of information. You will need to try again, call them later, and then hopefully they will pick up the phone, and then you'll be able to tell them what you wanted to tell them. And that's a perfect example for synchronous communication. On the other hand, we have SMS, which is an example of asynchronous communication, in which you can send a message to someone, and they will have the message stored on their mobile phone, and then you can go about your day. And once they are ready to consume that message, they can simply pick up their phone, read it, and then they have it at their own pace. MQ is flexible, and it allows you to deploy it wherever you want. As we said, you can have your applications written in different languages, and they can be hosted in different environments. And so is MQ. You can host MQ, and you can deploy it on-premise. You can deploy it in one of the most popular operating systems, such as Windows, Linux, IBM I, AIX, OpenShift, and so on. Or you can decide that you'd like to deploy it on your own public or private cloud, such as AWS, Microsoft Azure, IBM Cloud, my favorite, and Google Cloud. And if you'd like to let IBM handle all of the hard work for you, you can go with IBM Cloud, MQ Cloud option, and have MQ deployed automatically, and you can, within a few minutes, go right away and have your MQ ready for you to connect your applications. And be rest assured that whatever option you go with, your applications will have the same reliability, and the communication will be consistent across all of them. So how does MQ work? Before we talk about how it works, because I'm sure you're now interested, I've talked a lot about the value of MQ, and you really want to see it in action. Let's talk about the messaging objects that MQ uses to facilitate the communication. So this is self-evident. We have the messages, and they have something called the payload, which contains the data of the message or the content of the message. But they also have something called a descriptor. A descriptor tells the queue where this message is coming from, which application, and where it's supposed to go. And also, applications can have the option to add properties to a message if the consuming application needs to know a certain thing. And of course, we have queues. Queues, they have the messages in which they store them, and then they mediate, and they route them to where they're supposed to go. And we have the queue managers, and you can have as many queues as you want within a queue manager, and you can have standardized configurations that will be applied to all of your queues at once. And of course, your applications, they can be written in so many different languages, they can live in different environments, and they will be sending the messages to the queue, and they will be receiving the message from the queue as well. So, MQ can handle a large volume of messages from so many producers and so many consumers. And the cool thing about MQ, as you can see here, we have this queue in the middle. The message goes to the queue, and basically the queue facilitates the messages in the same order that they were sent. So the message producers, they can send their messages without having to worry about overwhelming the server. And the message consumers, they can also consume these messages at their own pace without having to worry about overwhelming the server or causing delays for other consumers. And this is what we call point-to-point messaging. In this case, message producers are the senders, and message consumers are the receivers. So basically, a message goes from one application, it goes right into the queue, and only once the server is good to go and the receiving application is up and live, it can consume that message at its own pace. So a perfect example of this, imagine we have a big e-commerce website for a company like Tesco, for example. Who knows Tesco? Yeah? I believe I'm the only one from the UK then. So let's say we have this big e-commerce website, and this e-commerce website needs to have a system that continuously updates the product stock. So it needs a system that updates the website's stock database. So how do we ensure that with a high volume of orders, there are continuous orders happening on the website, how do we ensure that the orders and their stock are being updated continuously on the database? Well, we can do that with point-to-point messaging. The orders will go to the queue, and whenever the server is available next, it can pick up that order and then update it in the database, and so it goes. Another example, banks. When your account balance changes, banks can send a message or a notification from its banking system to the customers using point-to-point, so it notifies you about your new account balance, and then customers can receive that notification in no time, with no delays, and with the correct information. Because the last thing you want to do, for example, is sending a transaction to someone or sending money to your friend, and then the banking server is down and nobody knows where that money is now. So we want to make sure that we have this reliability. We want to make sure that every message that's going out is going to be delivered eventually. Another pattern, and you will be familiar with this, is publish, subscribe. So publish, subscribe is built on the concept of topics. So the message producers, they are called publishers, and the message consumers, they are called subscribers. It is event-driven, and all of the interested consuming applications will get the message at once. So how does it work? The message producers, which are the publishers, and the message consumers, the subscribers, they agree on a name for a topic. In this case, we have baseball scores. In order for a message consumer to signal that they're interested in that topic, they create a subscription to it. And then when there's a new message to the topic, it gets sent to all of the consumers. So it's worth mentioning that if you just subscribe to the topic, you won't receive a history of all of the previous messages. You'll only receive the messages from the moment you subscribe to the topic. And you can relate to this because I'm sure each one of you have subscribed to a newsletter at least once in your life. When you subscribe to a newsletter, you don't receive all of the previous messages or the emails that were sent before. You start receiving the newsletters or the emails from the moment you subscribe, and that's exactly the model that this is based on. The third one is request response. So request response, and the best way to explain it, imagine yourself as the owner of a large and popular ticket resale website, And you want to secure a large number of tickets for a certain event before you sell them on your website. But before you do that, you want to ensure that event organizers have already secured your tickets before you publish them on your website. So how do you do that? With the magic of request response. Request response, which is also based on point-to-point messaging, but the only difference here is that once the producer application, which is called requester app in this case, sends a message to the consuming application, which is called response app, it waits for a reply. So it creates another temporary queue, and then it waits for feedback from the receiving application before it continues. So think of it as your secret agent that is going to secure your tickets, and it's waiting for the agent to provide them with the confirmation before it moves forward. How to get started? If you'd like to learn more about enterprise messaging, because today it was just an overview of how IBM MQ works, how enterprise messaging works, and I've shown the value of IBM MQ. But if you'd like to learn more about the technicalities, and if you'd like to experience the connection of having your applications communicate with each other, I highly recommend that you go to MQ Dev Essentials Learning Path, in which you'll be able to learn more about it, and you will earn an IBM credential at the end that you can flex with on LinkedIn. But if you're good to go, and you'd like to start connecting your applications right away, and again, your applications can be in any programming language, and they can be living in any environment, you can get started with MQ on Cloud on IBM Cloud, in which you can sign up for free as a developer. You can have your MQ, your queue manager and queues already there for you, deployed, and you can start with connecting your applications. And if you'd like to take it to the next level and scale the queue, you can pay as you go, and you'll only pay for what you use. And the cool thing about IBM Cloud, you don't need to use the terminal or a black screen to control your queue or see the messages that are being received. You can use a graphical user interface console to do just that. So here we can see the console. You click on Manage. You can see your queue manager, and we can see we have 3 queues inside the queue manager. You can have as many as you want. You click on a queue, and then you can see a list of your messages, and also you can create a message to be sent from the queue to the consuming applications right away from the console. You have this method, and you have the method which is accessing the terminal and doing just that, but this is a more visual way of achieving the same thing. And of course, we can see the message properties here that I just discussed from this console as well. And last but not least, MQ Ansible. Anyone heard of Ansible before? Cool. Ansible is an automation technology, and we utilize it in MQ to make it as easy as possible for you to get your queue and your queue manager deployed in no time. And this is one of the dear projects to me because I personally worked on it with a group of other developers at IBM. We automated the whole process, and you can literally deploy MQ on your virtual machines, whatever it is, and you can deploy it on 5, 10, 100 virtual machines with a simple click. And then once it is deployed, you can connect your applications right away. So I highly recommend that you check the GitHub repo. You can clone the GitHub repo, and then you can literally get started right away. And it is for free. So why not try it? I would love to connect with you all. If you have any questions, you can ask now, and I'll be happy to also answer further questions later on. You can connect with me on LinkedIn, or you can visit my website, mohammed@toom.com. And today, you understood the concept of enterprise messaging, how enterprise messaging is literally driving our modern world. You understood what IBM MQ is and how important it is to facilitate the communications between applications wherever they are and whatever language they are written in. So I hope you enjoyed it, and thank you. Any questions?
Hello again. Thank you for your presentation. I think it has been a good overview of what enterprise messaging is. So the question is, if we changed MQ to any other name, like Rabbit MQ,
Yeah.
the story would be very similar. So the question is, what are the key differentiators of MQ compared to, I don't know, Rabbit MQ or whatever, which come as open source solutions?
Right. Very good question. So, as he said, there are other competitors, right? And MQ really specializes in delivering your messages once and once only. Unlike other competitors, I'm not going to be name dropping here, that provide you with at least once or at most once messaging, which means that your messages might not be received at all or they might be duplicated. Plus, MQ has certain capabilities that I did not mention today, such as native HA and uniform clusters. What does this mean? This means you can auto-scale your infrastructure horizontally and vertically across the infrastructure in order to have higher availability for your applications. This means if one of the queues, for any reason, stopped working, automatically it creates another queue to make sure that the server is never down. I highly recommend you go to IBM Developer. I recently recorded 2 videos about native HA and uniform clusters. If you just write IBM Developer on YouTube, you'll be able to understand these 2 technologies that differentiate IBM Q from the rest of the competitors.
Okay, thank you.
No worries. All right, thank you very much.